Okay, in this video, I'm going to show you how to use a technique of anti-differentiation called integration by parts, which we call IBP for short. So first I need to remind you of the notion of a differential. So if v is some function of x, we can call v equals v of x. The differential dv is defined to be v prime of x dx. So for example, if v is equal to cosine of x, then dv is v prime of x, which is negative sine of x, times dx. Okay, so to get the differential dv, you differentiate v and multiply by dx. Okay, now let me show you the integration by parts formula. So the integration by parts formula says that what we do is we view our integral as being some function u times some function dv. And then what our integral is equal to is u times v minus the integral of v times du. Okay, so to apply this, we choose u to be some factor of the integrand, and dv is the rest. Okay, so I underlined factor here because it's important to note that what we're doing is viewing ours as u times dv, so u really is a factor. It's a bit different than u substitution because in u substitution, you could, for example, let u be a denominator. But in integration by parts, u is a factor of your integrand. dv is the rest, and it's also important to note that dv always contains dx because a differential has a dx in it. Okay, so now let me show you an example of using integration by parts. So the first thing we're going to do is we're going to choose some factor of the integrand to be u. I'm going to call x u, and then the rest is dv. So u is equal to x, and dv is equal to sine of x dx. So what you see, the integral is equal to u times v minus the integral of v times du. We know u and we know dv, but we don't know v and we don't know du, so we have to find those. Du is just the differential of u, and you remember that to get that, we differentiate u, and then we multiply by dx. So du is just equal to dx. V here is any antiderivative of sine of x that we want. Okay? So I'm going to show you in a little bit that we actually don't need the plus c. So when we integrate sine of x dx, we can just use the simplest antiderivative, which is negative cosine of x. Okay, so again, we do not need the plus c when we're finding v. Okay, so now what we do is we put all this together. So the integral of x sine of x dx is equal to u times v, so x times negative cosine of x, minus the integral of v times du. So negative cosine of x, and du is just dx. So here we get negative x cosine of x plus the integral of cosine of x dx, and that's equal to negative x cosine of x. Integral of cosine of x dx is plus sine of x plus some constant of integration. Okay, so here we wanted the family of antiderivatives of this, so that's why we have a plus c there. So what integration by parts did for us in this example is turn a complicated integral, or reduce a complicated integral into one that is much simpler to solve. Okay, let me have you do an example. Okay, so in this case, I have chosen u and dv for you, and I would like you to carry out the integration by parts formula to find out what the family of antiderivatives of this is. Press pause while you work on it. Okay, the first two things you should do are find du and find v. Then we plug them into the integration by parts formula. So we get u times v minus the integral of v times du. So that is equal to x plus 1 e to the x minus e to the x plus c. Okay, so that right there is the family of antiderivatives of x plus 1 times e to the x. Okay, now let me show you what happens. Well, actually, why you don't need to put a plus c when you're finding v. So here I'm going to evaluate this by letting u be equal to x and dv equal to e to the x dx. So then du is the derivative of x times dx, and v is the integral of e to the x dx. So I'm going to say that's equal to e to the x plus some constant of integration. So then I get the integral of x e to the x dx is equal to u times v minus the integral of v times du. Okay, so what we have is x times e to the x plus c minus the integral of this. So it's minus e to the x. Remember that c is a constant, so an antiderivative of c is c times x. Then plus some other constant of integration, c2. If I now distribute this x, I get x e to the x plus c times x. So what you see, no pun intended there, is that the cx cancels. So if we include a plus c when we find v, everything that is associated with that is going to cancel in the end anyway, so why bother? Okay, so let me recap here. The way you're going to solve an integral using integration by parts is that you choose some factor of the integrand to be u and the other factor to be dv. In the end, the hard part, once it's broken down, is integrating v times du. So there are a couple of things that you want to keep in mind when you are choosing u and choosing dv. One is you want u to have a simple derivative. And at the same time, we have to integrate dv to find v. So while you'd like u to have a simple derivative, we also have to be mindful of the fact that dv needs to be something we can integrate. Okay, the last thing I'd like to share with you is a mnemonic that's useful in helping you choose your u when you're using integration by parts. Okay, so the first thing that you should do, well, essentially you choose u in this order. If there's a logarithmic, then oftentimes it's helpful to let u be the logarithmic. Okay, so that's first. Next, if there's an inverse trig, okay, so you choose u in order of, in this order here. Okay, logarithmic over inverse trigonometric, over polynomial, over exponential, over trigonometric. Okay, so this is the precedence that you should use when you choose your u.